So welcome. How many of you were at my session this morning? Okay. Good sign when someone shows up again. Okay. Had a good conference today? Are you tired? Do you really want to go home? Am I keeping you? I'll try and make it as short and as pleasant as possible. I know that there's drinks involved afterwards, and you don't want to be the person in between drinks, and especially if they're free drinks. So, okay, so I'm going to give you a gentle introduction to reactive extensions. Just a small disclaimer, a couple of disclaimers. So, what is this session and what is it not? If how many of you here have done anything with reactive extensions? Okay. So this is a very, very, very low kind of beginner level introduction to the concept of reactive extensions. I'm going to cover a bunch of different things, what you can do with them, different ways to handle things. It's not deep dive. There's not going to be any advanced topics. So if you're familiar with the concept of reactive extensions, you're probably more familiar than you're probably more familiar than me. So you can get up on stage and do it. Or, as I said before, law of 2 feet. If you've seen it, go to another session. I won't hold it against you. I won't hold a grudge. Do leave your name. Okay. Why? I always kind of try and start my sessions with the why. Why we're doing this? Why do we do refactoring functional? Why are we doing reactive extensions? The reason we're doing reactive extension is because there's a thing called the Reactive Manifesto, right? How many of you have read this Reactive Manifesto? Right. How many of you have read the Agile Manifesto? Okay. We're very good in software development doing what? Creating manifestos. Right? Every time some new technology comes up, what do? We create a manifesto about it. And then we just jump on the manifesto bandwagon, and there you go. So we have to do reactive extensions. We have to work with reactive programming because there's a manifesto. Obviously not. There's a bunch of things that reactive offers us, and I'm not going to deep dive into this, but the manifesto outlines some of these characteristics of reactive programming in the terms that there's the responsiveness. So we want to try and create applications that are responsive because nobody likes an application that locks up. Something that's resilient, that basically is tolerant to fault. Something that's elastic because, hey, as I said before, we all need to scale. And something that's message driven, well, because that's a good factor in the sense of decoupling, so to speak. But I don't want to concentrate too much on this. I want to let's look at the other aspects of this and see what it tries to give us. How many of you are old enough to remember this? Right? There was a tweet the other day. It's kind of like saying, if hands up if you're old enough that you've experienced this. The windows hung and you had to drag this around and you used to make beautiful patterns. We still kind of have this, not in a different way. Now it's called Windows 10 or what have you, but you still, you get the blocking and stuff like that. But asynchronous programming is hard. It hasn't been really easy to do asynchronous programming. And yet applications required. I mean, if you think about any desktop application that you create nowadays, if you're still creating desktop applications, the last thing that you want to do is lock up the UI thread. The same thing happens with mobile applications. You don't want to lock up that thread while the user is trying to look for information or what have you, even if they can't do anything while you are doing the processing. You don't want to give that perception that the thread is locked up because, we, just like our users, are very click happy and we get very frustrated very easily, and we just want to crash out of the applications if we think that they've locked up. The web kind of has this dilemma as well because, we're moving more towards this very much more responsive web where we want basically everything to be instant, but we've jumped on another bandwagon which is called the single page applications because of this aspect of having a single page and just getting data back and forth very rapidly. And it's funny because our industry kind of self-imposes this, right? I don't think there's thousands of users out there saying we want software developers to make more responsive applications. No, we kind of push it ourselves and then we die trying. And there's also obviously the server side, and in this aspect, well, because we start to deal with many services, different data coming from different places, so it kind of we need this the responsiveness in that sense. Okay, so attempts to use it. There's been various attempts to kind of address this asynchronous programming. There's been threading. How many of you are old enough to have dealt with threads? Right, okay. Async await, many languages have introduced the concept of async await. In C# we have this concept of async await, whereby you basically make a call and then you await that call. The problem is that if any C# developers here, if you've done that, you kind of when the async await came in, everyone said, yeah, just decorate your methods with async await. And you ended up with async await everywhere, right? Absolutely everywhere. Now suddenly just your whole application became async await. And it's funny because I work in a language called Kotlin, and the examples here you're going to see in Kotlin, not probably. And one of the things that people are asking us is like, why don't you support asynchronicity at a language level? We're not going to introduce it. We're not going to provide that. We're not going to provide keywords like async await. We're going to delegate that to libraries such as Rx, Reactive Extensions, etc. Because to date, at least Andre, who's the language designer behind it, hasn't really found the solution that works great. And from the Java space, of course, you guys have probably used futures, so you've dealt with that. And then if you are have you ever done any callback hell with JavaScript? That is horrendously horrible. It's the tilted sideways Christmas tree, right? That you just go call back and call back and call back and call back and call back. So there's been attempts to ease that. And all of these attempts, well, they're not that simple. And of course, well, there's other ways in JavaScript promises to kind of resemble the whole futures aspect. And the issues with this is that, first of all, we've got this big problem of combining asynchronous operations. So the whole concept of the callback with callback with callback leads to this problem of I need one result from one callback to then combine that with the other result and so on and so forth. And the other issue is, if you actually think about it, different techniques use different techniques for different languages. So the majority of us here, whether we like it or not, have become polyglot developers, right? There's always been our Java, our C#, or what have you, and then someone came and slapped us in the face and said, you got to do JavaScript as well. Whether you like it or not, you're going to have to do JavaScript, okay? So there is the need to now know multiple languages. And, if I have to deal with different ways of doing different things in different languages, whereby I can try and provide a more uniform way, then it would be much simpler, right? Because the less things that fit in our head, the better. And that's where this whole concept of reactive extensions come in. Now this is, and we'll get into this a little bit later, but Rx initiated with, in C# by Eric Meyer, and it was called Reactive Extensions. And in the Java space, at some point, Netflix, which I'm sure you've all heard of, has started to port this over to the JVM space and offered it under Netflix. Now it's got its own domain. It's an open source project. And this is RxJava. And RxJava would probably not be the most appropriate name for it. It would probably be better to call it RxJVM because it's referring to Java as an ecosystem, because it actually has support for multiple languages, right? So Rx has become this platform, or sorry, this library in which multiple languages are now supported. In fact, if you go to the website, well, we'll see in a minute. The one thing to kind of highlight here is this concept of observable streams, okay? So an API for asynchronous programming with observable streams. So let's just say everything is a stream and it's observable, right? So I'll throw that out at you and you're kind of like, what the hell did I just say, right? Well, I mean, what is a stream? What is observable? What exactly does that mean? So let's step back and take a look a little bit at what we're trying to do here. So who can answer me this, like, what is programming? You're all, okay, how many developers here? Come on, let's liven this up a little bit. Come on, people. Okay, you're all developers. No, you're not. There's a few people that didn't put up their hand. What are you?
Tell the computer what you want to do.
Tell the computer what you want to do. No, the correct answer to what is programming is an art, right? And we are all craftspeople, okay? You agree with that? Sure. Otherwise, the craftsmanship manifesto wouldn't sell well, would it? You're going to go around calling yourself a craftsman. Actually, all we do is really just process data, right? If you think about it, that's all we're doing. And I love this picture. I've shown it at all my talks, and that's because I took this picture myself. It's a distillery from Islay in Scotland. And I also love whiskey. But all we do... Whiskey without the E, okay? Bourbon is so-so. But what we're doing is basically, all we do is just like process data, right? And it's a very glamorous job. Some people call themselves rock stars. Crazy people call themselves ninjas. But that's what we're doing. We're just like processing data. Normally we end up in large offices like this with little cubicles, although now they're trying to go cheap. So instead of having our own cubicles, they now call it open spaces offices. But at the end of the day, all we're doing is just processing data. It's not a very glamorous job, but it's one of the best paid jobs ever. So, as long as they pay us well, we'll just continue to process data. But jokes aside, we do provide better value than just processing data. But if you think about it, we just got, a whole bunch of data, and we've got a whole bunch of functions that we can apply to this data. That's it. Really, if we think about it, that is it. And this data comes in various forms. And if you were in my presentation this morning, you saw this slide as well. We have scalars, we have individual values, we have date of birth, we have sales, we have amounts, we have names. Then we have a collection of data like list of countries, collection of customers, etc. Okay? So let's go and do some data processing just to get up to speed with some of the constructs that I'm going to use in this presentation. Okay? So I'll just go over some demos here and show you some data processing techniques. So I'm very much hoping that I actually changed the font to this. So one of the things that you should never do is so I use you can see that okay, or still not. Is it blurry at the back? It's okay. I actually had it all set up because this is not something you actually do during a presentation. I had it all set up. I made the bad mistake of using an early access program version of IntelliJ, and it was working all fine until last night it says, this build's expired. And the new build was breaking for me. So I had to revert to an old version. If only those people at JetBrains knew how to make tools. Okay, so let me show you, this is very, very simple, and you see it. Just to get you a little bit up to speed with the context that we have here and the language that we're using and stuff like this. So this is Kotlin. How many of you heard of it that didn't hear it mentioned in my talk this morning? Okay, it's a 100% interoperable language with Java. It's built by us. It's open source. It's built for us. But we decided to make it open source because in this day and age it would be crazy to actually release a language that is not open source unless, of course, you're Apple, and it's called Swift. So we made it open source. We're going to release it this year, hopefully, and you're more than welcome to use it. I like it because having come from C#, I've never been a big Java fan, and this is quite concise. It's also got the conciseness of JavaScript. It doesn't have the craziness of JavaScript, and it's a statically typed language. Okay, just to go through some constructs so that you're familiar with the rest of the code. What I've got here is Kotlin has this concept of like a main, just like you have a static void main in Java. There's no reason to have a class, so I can just open a file and dump a function in, kind of like JavaScript. And here I have just a file called main, and this is going to execute. Okay, and if I run this, it's going to do some things. And what exactly is it going to do? Well, this line basically is a list of numbers. Okay, so, and that's not exactly what I wanted to do. Let's do it another way, because I'll show you that. Let's do it like that. Okay, so that's a list of numbers, and then what I'm doing is just looping through those numbers and I'm printing those numbers. And then in the next line, I'm doing exactly the same thing, except I'm doing it with a different construct, which is using a for each function, which actually, if I drill into this, you will see that it's just a function that takes a function and returns void. Void in Kotlin means, void unit in Kotlin is void, okay? So this is more kind of like a higher order function. It takes a function. And so instead of a for each loop, I'm just doing it as a function. And then I can just do that in a different way. This is a lambda expression in Kotlin. In Kotlin, we also have the convention that if the last argument to a function is a function, I don't need to pass in the brackets. I can just pass it in without brackets. So what that means is that then I can get nice little syntax, DSL-ish things like that over here, okay? It is also a convention that you'll see throughout the code, which means that if the function only has a single parameter, I don't have to explicitly name it, I can just refer to it by it. Okay? Everyone following the syntax? Very simple, right? You all understand that without me even having to explain it, right? Brilliant. That's one of the objectives as well, for Java developers to read Kotlin easily. Here's another example. What I'm doing here is using the concept of flat map. If you're not familiar with, if you weren't here this morning, basically flat map, what it does is if you have a list of elements, so you know what map does, right? Map basically gets an input and applies a function and maps it to some output. With flat map, sometimes we don't have a flat structure, we have like a tree structure. So what flat map will do is kind of flatten it out, do the mapping operation and then flatten it out and just give you one list collection. So here what I have is a list of albums, and if we drill into albums, we'll see that it's just a list of albums, and each album has a track. And what I want to do is get a list of albums with the track in titles, etc. So I'm just creating an album and the title. Oh, sorry. What I'm doing here is basically looking for albums that have the in any track title. Okay? So I get the album, I filter uppercase for the title that contains the, and then I map it to a new pair, which is album and title. Okay? And then I just print it out. So this will basically just give me a list of albums that have the word title, the word the in them. Now, we can also do kind of like combining of things. So here, for instance, what I'm doing is I've got a list of numbers, and then on those numbers, I'm going to filter those that are divisible by 2, modulus 2, and then get the last number. So that's basically returning a scalar. Okay? Everyone's clear with that, right? That's very simple, easy to follow, right? The key point here, of course, is that I want you to see that here I have basically functions that take functions, and they're returning collections, and then on those collections I can apply more functions, and I'm basically iterating, looping over these, and I can also obtain scalars from functions. Okay? So let's go back to slides for now. So if you look at what we've done here is we've got this iterable, which you're all familiar with in Java, or an IEnumerable in C#, and then we have this iterator or IEnumerator, and what I'm doing is basically iterating through a collection of items, okay? And I'm just calling next and then returning the next value, and there's a function that tells me whether there is an actual next value, a pattern that we're all familiar with. All we're doing is just iterating over data. The problem, of course, is that when we're iterating over this data, what we're doing is effectively blocking the thread on which we're calling this iteration, right? So all of those examples that you saw there, as soon as I do number print line each, what I'm doing now is effectively blocking that thread, okay? And if that's the main thread of the application, it would block up all the UI thread or anything like that. So, of course, this example doesn't mean much, but if you replace it with something like, database get customers by country, and then on that filter for those that, match profession agriculture, and then on that get the growth figures by a city, and then display the growth, all of these are basically going to block the thread, right? And that is what we're trying to avoid. Because we shouldn't block. That's the whole purpose, right? I mean, the whole purpose of this talk is not to block. And why are we blocking? Because we're waiting for data. right? We're basically looping over data and we're waiting for data. We're making a call and we're waiting for data. That is the reason that we're blocking. So why don't we like twist this around and just say, why don't I get notified when there is data? Right? Because we're very familiar with that concept, right? We're familiar with the concept of getting notified by something. If you've ever done any kind of like message processing or event-driven architecture, you're more than familiar with this concept of a message is launched and I get notified when that message comes in. In essence, what I'm saying is, why shouldn't we just have like this event that's called onDataReady event? And when that onDataReady event comes in, I just fire some procedure, some call that does something with that data. That's effectively what I want. Why, instead of like looping and pulling, why don't I just push? And this is a quote by Eric Meyer, the guy that came up with reactive extensions, and he says, what is the difference between an array and events? And if you think about it, there really isn't any difference between an array and events. Right? There is no difference. And if you think about an array like a list of elements, how is that different from a list of some event, some data that is firing? How is that different, like the typical example they put? How is that different from the mouse being moved and the coordinates being sent out? How is that different from a key being pressed and that data being sent out? It's all just a list of elements. Right? The difference is there is no difference. Right? So, how many of you are familiar with the observer pattern? Right? The observer pattern, basically what it does is you observe something and then get notified when information is available. Now here is, back to that iterable, we have this iterable and we have this iterator, and what we're doing is pulling data. Right? So why don't we like kind of convert this into a concept of pushing data? So instead of pulling data, we're going to push data. And we're going to come up with these two interfaces, which I'll tell you how you arrive to this in a minute. And instead of like pulling data, what we're going to do is push this out. So instead of doing like a get next, we're going to have an on next. So you see, we're following this pattern of on events. Instead of is there a next, we're going to have an on completed. We're also going to separate out the concept of on next and on next error, because we want to try and amplify this and provide some other things. And so this now becomes like what was before our iterator, and the iterable now becomes an observer. So instead of now looping through this list of elements, what I'm going to do is just subscribe to it. I'm just going to subscribe to it, and when some information comes in, I'm going to get notified that there's an on next, and then when it finishes, I'm going to get notified that there's an on completed, and when there's an error, I'm going to get notified that there's an on error. Now this thing that I just merged from pulling data to pushing data is this concept in mathematics called duality. Have you heard of duality? Right? So if you haven't, like the best source in the world, my son said the other day, he's like, we were arguing about something. Okay, not arguing. You don't argue with your kid. You debate things with your kid. You don't believe that, do you? So we're arguing about something, and he goes, no, I read this on Wikipedia. It must be true. Poor kid, naive. Anyway, so I found this on Wikipedia, which is my source of information as well. And it says, in mathematics, a duality, generally speaking, translates concepts, theorems, or mathematical structures into other concepts, theorems, or structures in a one-to-one fashion, often by means of involution operation. If dual of A is B, then dual of B is? That's for you to say? A. There you go. I left that out on purpose. No, I didn't. Actually, that got cut off. So involution function is basically a function in which you apply the function to a value, it returns the value itself. Okay? So what we've actually done is provide a duality of the iterable. And that duality of the iterable has become the observable. Right? In fact, how many of you know Eric Myers? Really? Okay. He's like one of the gods of programming. He's one of the guys behind C#. The company his company now is called Applied Duality, which kind of makes sense now in the context of what he came up with reactive extension. And a simpler example of duality is the law of De Morgan, which I'm sure you're all familiar with, right? If I negate A and B equals not A or not B, and the negation of not A not B equals not A and B. Okay, so those are examples of duality. So in essence, what all this means is that reactive extensions is just an extension of the observer pattern, right, in which we have this new kind of constructs and we have these like events of on next, on error, on completed. And then we have a whole bunch of operators to work with this observable patterns, with this observer and this observable. And what I'm effectively doing, what they're doing is abstracting a lot of the low-level stuff, like the threading and the things that we normally have to deal with when we're creating a synchronous operation, when we're working in a synchronous way. Now, I've highlighted this operators because this is really important, and this is like one of the main factors of Rx is that really there is a whole bunch of operators. In fact, that's kind of like the idea of why it's called extensions. Right? In C# there was this concept of extension methods, and what you were doing is adding extensions to IEnumerables, in the IObservables, right? So we'll see some of these operators, but these are the key things. These are all of the things that it provides you. So you have ways to create observables, and we'll use some of these, we'll see these. We have ways to transform observables, to filter observables, to combine observables with error handling. Utility operators, a whole bunch of things. Now, if you look at the examples that I showed you before with all of the functional stuff, right, where I had basically lists and I had operations on list, this is the exact same thing, except instead of getting collections, what we're going to be operating on is observables. So instead of getting a collections of integers, we're going to be operating on observables of integers. And all of these observables all have operators that we can work with. Okay? Reactive extensions right now in different forms, some under the umbrella of RxJava, which is if you go to Reactive, RxJava is a library by Netflix, as I mentioned to you, is available for all of these languages, right? So it doesn't matter unless, okay, it's not available for OCaml, if anyone's doing OCaml, but it's available for all of these languages. So really, and this is a key important thing, because now what happens is that we are now, if we jump on this manifesto of reactive programming and we learn this way of doing programming, now we have a common set of APIs that we can use independently of our programming language. Okay. Yes, there are a few differences if you go from Java to C#. For example, you have IEnumerable, IIterable, and things like that. IObservable, you drop the I in Java, but more or less it's the same thing. Okay. There's also a bunch of frameworks or libraries or extensions that are available, which we'll kind of see what the meaning about that is that they're providing you with like an API to reactive programming. So Netty, how many of you have heard of Netty? Which is a fantastic, very high performant for TCP and HTTP applications on the JVM, and it makes me laugh when people you see the post that they say we moved over to Node.js for performance. No, my friend, you didn't. You moved because you probably wanted to play with JavaScript. We have Rx React, which is actually out new, which is reactive extensions for React.js, which I'm sure you've heard of. Rx Android, and I think there's a session tomorrow on using retrofit with reactive extensions for Android. So if you're in Android development, check that out. RxUI, which started out as actually WPF in C#, and now it's basically a UI for all kind of the desktop application development, whether you're using Cocoa, whether you for Objective-C, iOS, or you're using .NET, WPF, Silverlight, etc. So there's a lot of work in the community going on around this. And it's great because it provides us with a homogeneous interface. Now, from here on, apart from a few slides at the end, we're just going to do all the demos. Okay? Right. So the first demo I'm going to show you is the one that kind of scares you and says, do I really have to do this? Okay. So let's go to an observable. Okay. So here what I have is, go away. Here what I have is the full-blown implementation, right? So if you think about it, what I'm trying to do here is I have this thing called, can you stop looking at the screen? I have this thing called an observable, right? And I have this thing called an observer, right? And the observable is basically getting data from somewhere, and it's going to, when it gets data, it's going to push it out and say, hey, I got data. And an observer, what it does is subscribe to this observable. So always there's these two things at play. I don't want to say the word subject because subject is something else. But there's these two entities at play, an observable and an observer. Okay? So let's go back to that. And this up here, don't be scared because you normally don't have to do this. This is kind of like the full-blown, I'm going to create an observable, and here's a lot of code that I would probably have to implement. A lot of the observables are actually implemented for you. And what I'm doing here is actually I'm inheriting from this thing in RxJava, which is called unsubscribe from iterable. So basically what it just means is that I'm going to create an observable that is going to subscribe to an iterable list of elements and then spit them out. Okay, we'll see there's a shortcut to do this. And now here's the interesting one, which is the actual observer. So the observer has three main methods, which we saw earlier, which is the onNext, which means that something is available, the onCompleted, which means that it's completed, and then an onError in case an error is thrown. Now what I'm doing is I'm saying create an observable with a list of elements, with an iterable, right? And then I'm going to create an observer, which is an instance of this observer. In Kotlin, there's no new keyword, okay? So that's why you don't see the new keyword. And then what I'm going to do is with that observable, I'm going to subscribe this observer, okay? And if we run this, what happens is that basically, as soon as I run this, the subscribe kicks in and it says, okay, get the observer going, and we'll see the difference because there's two concepts with observer, which we'll see later on, which is hot and cold. But for now, just assume that when I hit subscribe, it's going to kick in the observer, the observable. And then it says, okay, I've received an element A, I've received an element B, I've received an element C, and the sequence is completed. Okay? Now, that you kind of look and you're like, how the hell is that different to what I've just seen with a list that you've looped through? Right? How is that different? Well, we'll get to the synchronicity of that a little bit later. Obviously, all of these demos here is this is a console application, right? So what you've got to be aware of is that, there is a single thread, it's a console application. When you're doing actually this in development, you normally have multiple threads, and you have your background thread, you have your UI thread, etc. Okay? But we'll see all of the threading issues a little bit later. So I can actually make that a little bit easier, and what I can do is I can, instead of inheriting from this observable class and then from observable from iterable, what I can actually do is use a factory method. So you can actually do observable create, and then here you can pass in either function, a lambda, or an anonymous object. In Kotlin, to create an anonymous object, you just create object : the name of the class that you want to implement, and then you override the method. There's one single method here, which is call, right? So imagine that what is happening here, now here I'm just doing onNext, 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 but ideally what's happening here is that it's actually going to some external resource, we'll see this a little bit later on, that is just pulling data in, and once it gets that data, it pushes it out, right? So every time an onNext is called, the observer, all of the observers subscribing to this are going to get notified, and then they're going to get this onNext, right? So if you run this, what is it going to produce? Exactly the same as we saw before. A refactored version of this, which is similar, but now instead of using that anonymous object, is just making it shorter, is using lambda. Okay, so here I have a subscriber of string, and then I've got a list of strings. I'm going to loop through the strings on each iteration. I'm going to call string onNext, and then I'm going to call completed. And again, if we run this, it's going to give us exactly the same result. No, except this time it doesn't say element A, element B, element C. Okay, but it's basically the same concept. Okay, so those are various ways to create observables from a list of iterables. Now, RxJava provides you with even more facilities with that. By the way, one thing I want to mention here. RxJava comes with adapters for different languages, right? So if you, for example, you're using Java, you can just interact with RxJava directly. If you're using Scala, you can use the Scala extensions. So it provides a more idiomatic version of Scala code. If you're using Kotlin, you can use the Kotlin extension. So what that would do is, instead of me creating with the Kotlin extension, instead of doing observable create, I would just call a function called observable and pass in a lambda. So it makes it cleaner. I didn't do this on purpose because, first of all, you'll see that it's, Kotlin can completely call Java without any issues. And second of all, I want you to see the full-blown pictures, okay? Not hidden under any other functions. But once you start to use this, you can use your different extensions for different languages. So it supports Scala, Clojure, Kotlin, and a couple more, I think Groovy as well. Yeah, I think so. Anyway, now the other version is over here, which is from, okay? So I can even cut that down shorter. Instead of having to create that object or that anonymous, that lambda expression, what I can just say is create an observable from a list of iterables. Okay? Now, notice here, this is what you just saw before, right? But here I'm doing another thing. In this case, subscribe only takes, if we actually do, let me show you, if I do observable subscribe, you see that it can take multiple parameters, right? So if I only pass in a single lambda expression, what that means is that it's just a lambda expression for what happens in the onNext, okay? If I want to provide the full-blown thing, which you actually have to, you should, that's what you do. So it's actually 3 different lambda expressions. What happens when I do an onNext, what happens when an error is thrown, and what happens when the sequence is completed. And if you run this, it will show you basically just the element and then a sequence completed, because in this case there's no error that's going to be thrown. We'll see that later on as well. Okay? So that would be the full version. Okay. Any questions so far? No? Okay. You are an awesome bunch. I love audiences that don't ask questions. Yes, and now someone's asked a question.
What is different from asynchronous programming?
So the question is, what is different from asynchronous programming? Nothing. We are doing asynchronous programming. It's just a different API to do asynchronous programming. Okay? Yes?
Is there any way to specify affinity, like thread CPU affinity?
Yes, we'll see that. So the question is if there's any way to specify affinity with different CPUs, which thread it should be running on and stuff like that. Yeah, we'll see that a little bit later on. Okay? Yes?
Is there a way to write that subscribe statement more literally so that you understand that the first is for, so you understand which method you're doing instead of just having an array of lambdas?
Okay, so the question is if I can be more explicit with the lambdas that I'm passing in. Again, if you use Rx Kotlin extensions, yes. One of the things that Kotlin provides you is the ability to give named parameters. So you could actually say, onNext equals this, on that. But you have to use the Kotlin extensions because you cannot provide named parameters to Java calls. If you're using Java, yes, then you would use it would be more explicit. Also, I mean, if I don't have to write it here, I could say, for example, this could be onNext, right? onNext, and then here, this would be onNext. Okay, so that already gives you insight into which method that is, whether it's an onError, whether it's an onNext, etc. Okay, and much like Groovy, Kotlin has this concept of using it, but if you overuse it, it can become horrible. Okay, so you have to be cautious, like anything, don't abuse the system. Don't ask too many questions, and everything will be okay. Okay, yes?
If you added then at the end of this program an element to that array, you print it out, wouldn't it?
What, here?
Yeah.
Yeah. So you're saying, like, say, for example, print line something. Yes, and we'll see why, how, where that happens when we look at a little bit of the threading stuff, okay? So, yeah, that will run. So one of the beautiful things that Kotlin has is that it's still not as fast as Java when it compiles, but it's faster than Scala. Okay, so you see the something here. Okay, so now what I want to do is, here's another example. Okay, now this is another built-in function in RxJava, which is called interval. And what interval does is basically take a starting value, take a unit of time, and then just start to spit out information. Okay, so I'm going to run this. What do you think is going to happen? So basically, what that's saying is start from interval of start emitting values every second. Okay, so 1 time unit second. If I run this, what do you expect to happen?
Event generated every second.
Pardon?
An event generated every second.
Okay.
Yeah, I won't do anything because you've already exited the thread.
You are not anything.
Nothing. I'm not getting anything. Why? Yeah, because it's running, but I've exited the program, right? Now, obviously, if I do this in a program where I actually have a continuous thread running, then that will do something. So here's a little hack, and I'll show you how you can like do this in a different way later on. But if I run this now, you can see that it should work, because now I'm just like, okay. And well, once we look at some of the threading stuff, we'll see where all of this comes in. Some things might not make sense. In fact, they don't make sense to me still either. I'm by no means an expert in this. Okay, so now we've got this. Let me show you something else. So what I can do now, of course, this is meaningless, right? Right now, all I'm doing is just doing stuff with like, big deal. What I can now do is start to combine these things. Right? So just like we saw with lists of elements, I can do the same thing with observables. And notice, please be aware that we're not returning lists of elements. Every call is returning a new observable, and this is something very important. So here I say, for example, observable 1 to 100, right? And if I run this, what it's going to do, it's going to take those observables. It's going to find those that are divisible by 4, that's by 2, modulus 2, and then it's going to return a list of observables. On that list of observables, it's then going to multiply it by 10, and then it's going to filter it by modulus 7, and then for that, it's going to start printing. Now the for each, notice that there I don't have an actual subscribe. For each actually subscribes to the observable, and that's what kicks it off. Okay, so if I drill into for each, you can see that what I'm doing is actually calling subscribe, right? Now the thing here is that each of these is actually returning an observable, and it does this by using this operator, which is called lift, right? Lift you'll come across, and what lift does is basically take a list, a result of calling an observable, and then create a new observable from that. Right? Okay, so we've seen these ones over here. So now let's go and look at, for example, combining observables. Okay, so you saw that some of the operators that I showed you, right? We have all of these different operators available. We have combine latest, we have this, we have that. All of these different operators are variable. And what I'm doing here, for example, is I have a list of numbers from 1 to 10. I have a list of letters from A to J. And then I'm going to take that list of numbers and I'm going to zip it. So I'm going to take the first observable collection and I'm going to zip that with the second observable collection, applying this function. And then once I do that, for each, again, subscribe to it and do something with the result. This is just a different way of doing the same thing. On this one, I'm calling zip with. On a specific observable, zip with. Another instance, on this one, I'm just calling a static method, take zip these two observables. Okay? So you can see that it's producing, well, similar results. The only difference is that I just created the pair differently here. Okay? Notice here, again, I'm using for each. Here, I'm using subscribe. Okay, and in fact, I was going to show you this at the end, but all of these are like the operators combining zip with and then combine latest, join, etc. And if you go to RX Marbles, which is a very good website, how many of you have seen this website? Very cool. It's a website which basically, so one of the things that they say when you're doing reactive programming and when you're working with RX Java is to try and visualize things with all of these like marbles, because effectively what you're doing is over time you are sending values, right? And sometimes it's not easy to visualize what's happening here, what's happening with these values. So RX Marble is by Andrei Stoltz, if I said his name correctly. And what it does is kind of look at all the operators, and then you can click on it and it shows you the behavior of what's happening, right? So in fact, before I show you this, if I switch over, you can see, for example, if I do a zip with, if I look at JavaDoc, it will show me it as well, right? It's going to show me like, this is what's happening, right? But this is a static image. What the cool thing about RX Marbles is that I can actually move all of these, right? So as I move these, it shows me the behavior. So for example, if I go to combine latest and I start to move this, you see how the behavior of that would occur. And it's very, very good to visualize sometimes when you're not too sure exactly, why things are happening the way they're happening, because that's one of the things that's kind of like puts you off with RX a lot of times. You're like, what just, what just happened? So that's a very good thing to see when you're looking at the different operators. Okay, now let's go ahead and let me show you. We've got these ones over here. We've seen this one. Okay, so error handling. Now this is when we come to the whole error handling thing. Okay, so here I've got an observable. I've done the full-blown observable thing. So you can imagine again that here all I'm doing is just basically sending out random numbers. I mean, looping through numbers, right? But what I'm actually, this is going to be a call to a database. It's going to be something or other. Okay. And what I'm doing here is I'm looping through a list of numbers. I'm doing 100 sleep so that we get some timing in there. And then I'm calling on next. And then I'm just randomizing a number. And if that number is divisible by 5, I'm going to throw an error. Okay? And I'm not going to throw an exception. In observable, what you have to do is call on error with the actual exception that you want to throw, but you never throw. You call on error. Forget that if T1 is unsubscribed for a minute, and then here I do T1 uncompleted. So down here is the first example of executing this, of how to handle errors. Okay, so if we uncomment this, what I'm doing here is I'm going to say I'm going to map, and I'm going to receive each observable, and then I'm going to subscribe to it and print it. What happens if we run this? Eventually it's going to stop. It's going to blow up, because at some point, hopefully we'll find a number that's divisible. Oh, there we go. It blew up. Okay, so it received 1, it blew up. I mean, I can run this again and probably it will give me another value. It received 2 and it blew up. If I run it again, it might receive 1 and blow up, right? And so what's happening here is that right now all I'm doing is saying, okay, this is blown up. And I stop. And that's one of the conditions. Like, an observable has to have a series of a contract. It has to abide by a contract. And one of those contracts is if an error occurs, you stop. You stop emitting observables. Now, where things start to get interesting and where RX starts to provide you with a lot of value is things like this. I can build in, for example, retries. And I can say, if it fails, let's retry. And I can say how many times I want to retry. So this says, let's retry. In this case, it's number of times. I want to retry once. So if I run this, what's going to happen? It's going to run, and if there's an exception, it's going to say, okay, I'm going to continue one more time. If I put 5, you see, it works a little bit more, and it stops, right? If I run it again, it stops on a smaller number. So you see, Okay, so it's running an error has occurred, and it said, okay, an error has occurred, but I'll still try one more time. And this is just the number of counts, and it offers you a bunch of other ways to control errors. So for example, you can actually say, retry based on a specific predicate. So I say this is basically, I'm doing a type check, and I say that ignore any kind of errors that are of type number exception, right? So if I run this, it's going to ignore errors of type number exception, and it's always going to run, right? It will always go until 20. If there's any other error, then it will stop, right? And this is where it starts to get cool, because you start to say, okay, I'm going to make a web service call, and I'm going to wait, because there's also a timeout. I'm going to wait 5 seconds, and after 5 seconds, I'm going to retry if there's an error, and you start to chain these calls, and what you're doing is basically chaining different calls to asynchronous operations in a very fluent, easy way to read, much like some of the benefits that we were seeing with functional programming. Right? All we're doing is just applying functions in a pipeline to observables. Okay? Now, let's go here and let's take a look at blocking. Okay? Now, this is kind of like an anti-pattern. Okay? This is something that you shouldn't normally do in observables, because here I have an interval. Remember the example that we saw initially, where I was basically running interval and I ran it and nothing printed out? Right? Because the main thread quit. This is an example of exactly why you shouldn't call blocking. Because what you're doing now is actually you're blocking that thread. So you can take any observable and convert it to a blocking observable. Right? But it kind of goes against all of the synchronous programming that we're trying to accomplish. Right? We're not trying to ever do a blocking. So use this sparingly. There are situations where you want to, for example, combine two observables, and you need, for instance, to block on one of them for whatever the reason, or you need to block the thread for whatever the reason. There is mechanisms to do that. But this is a way to show you that how actually now I can block that main thread, and I can continue to subscribe to this and get information out. Now, before we do this, let me show you, hold on, okay. So now here's a little bit full-blown option. What I'm going to do here is I've got basically a data server, a socket server, that is going to fire off some data from a socket. So this is kind of like a more real-world example. Okay, so I have some socket server here that I'm going to connect to, and I'm going to start get information on. Right? In this case, what I'm doing is I'm connecting to a socket server. And I'll tell you a different way of doing this in a minute. But I'm connecting to a socket server, and then on the call, basically, I'm reading a line from the socket server. If it's not null, I'm calling on next, and then I'm reading another line. And once I finish reading all the lines, I call on completed. I close the socket, I close the reader, and done. And in the observable, what I'm doing is basically getting information from that socket, and I want to filter out lines, specific lines, okay? So this is actually sending me information from a file I have here called an access log. So you can imagine that this is your typical HTTP file, access log that you're sending. And if I run this, basically what this is going to do is just run, start to listen to that socket, and then once it finds a pattern that matches that, it starts to print this out, right? This is where it starts to become beautiful. This is like now I can imagine all of the things that you could now do this with this. I can have an access log, and if there's a specific entry, then I can fire off a different observable to try and see if there's another entry that matches, and then zip those up and provide a value at the end, right? In a very, very easy, simple way. And these kinds of calls that you're seeing here, of course, you don't have to implement this manually, because that's where some of the extensions with RxJava come in. That's where RxNeti comes in. A lot of this is already done for you. And in fact, here what I'm doing is I'm doing an on-call, and I'm actually creating a resource, and then I'm disposing of that resource. But there is an override of observable create, not of observable create. It's observable, where is it? Using, which allows me to pass in all the resources that are being used, then the block of code that I'm actually going to do work with, and then dispose of that, right? And disposing of it is one of the important things in observables, because we haven't mentioned that, and that's what I'm going to see now. So notice here, actually show this. Here I had this call which is unsubscribed, right? So let me go back here to combining and show you something here. Take a look at this. There's actually no call here to unsubscribe, right? There is no unsubscribe here, right? But in observables, it's very important when you're implementing observables to manage subscriptions, right? So every time when I take an observable and I call a filter on it, for example, what's going to happen is that it's going to do a lift. So it's going to create an observable of those elements, right? So now I have the first observable, and now I've got a second observable that is creating a kind of like a, you know, an observable from the results of the first one, and then I can chain another one to it, and I can chain another one to it, right? And now at the beginning it starts to send observables, and this one's going to send observable, this one's going to send the observable, and so on and so forth. Imagine if the first one, or somewhere in the middle, there's a socket, right? When do we close that socket? When do we close that resource? It is very important that every single observable, once they've finished listening to that once they're finished listening in that chain, they should unsubscribe from that observable. And to unsubscribe, the observable actually needs to respect this unsubscription, right? So here, if I run this, what I'm doing is I'm saying emit values until there is no longer anyone subscribed to it. So sorry, until the subscriber is no longer subscribed to it. If I don't respect that, then you start to run into memory leaks, into resource management issues, right? So you have to make sure that every single value is, every single step in that pipeline does the unsubscription, okay? It's a little bit like more advanced aspects of RxJava, but I want to mention it because you need to look at that when you start to work with it. Okay, there's a couple more examples I'm going to go through, and then we should be done. And this is where you kind of try to, hopefully, will look a little, see a little bit, understand what's happening behind the scenes. Okay, so one of the aspects that I said that RxJava tries to get rid of is the whole dealing with threading, etc., right? It tries to abstract that up. Here you've seen what happens here, okay? This is the typical examples that we've seen all through the day, well, all through this session. If I run this, it's going to execute the first version of this. So this is observable, don't look at that. This is observable from 1 to 20, observable subscribe, receiving it on thread name. Now look at this, on main. Thread name is just a little function that just gives me the actual thread name, okay? That's what we've been seeing so far.
Can I ask you a question with respect to previous unsubscribe?
Yes.
Here we are saying that, okay, this observable can only emit 10 elements, right? Even then, do you think that I need to specifically say observable.unsubscribe?
This is a finite set. So once it's done, it's completed, it's finished, it's gone, right?
So only if it is infinite string, then it makes sense for us to unsubscribe.
Yes, and if it's holding up resources, right? But any operator that you implement, like you normally wouldn't implement operators in RxJava, like because map, filter, all of these are there. But if you ever do, you need to respect unsubscriptions, because what will happen is that, let's say for example, there's an operator in RxJava which is called take. And take, you can pass in a number and you can say, subscribe to this observable, take 20 and done. You need to respect that, because as soon as it hits 20, it should now say, okay, I'm done. right? And it should say the observable to which it's subscribing should respect the unsubscribe. So when it says this one says I'm completed, it should respect it up the chain.
So there are two aspects of unsubscribing. The client contract you are saying is that it need to call unsubscribe, and on the observable side, it should check for if observable has unsubscribed or not.
Yeah. So the question is, there's two aspects of unsubscribe. There's not two aspects. There's a single contract of unsubscription, but both parties need to comply with it, right? Which is done with the uncompleted. So an observable should always emit an uncompleted once it is finished. Okay? Now, let's take a look at the next example. Here, what we can do is, I'm going to comment this out, and I'm going to use this thing called the computation thread. Okay? And what this does is, I'm going to run this, and you'll see. So what this is doing is creating the interval, as we saw before, and then it's doing a subscribe, and let's see where it actually receives that value. And then I'm going to print the thread name of the current value, and I'm going to do like a while true so that this actually works, okay, because I didn't call to blocking. Now notice what's happened there. This is still the main thread. However, the observable is now working on a different thread. Okay? It's working on this thread called the computation thread pool. Right? And when I'll show you schedulers in a second, and there's different threads. Schedulers is basically this abstraction in Rx to allow you to define what thread, how to work. There is a thread, there's a scheduler for using computation, for resource intensive work. There is which uses a thread pool. There's an IO one, which is for IO operations. There's an immediate, which means immediately execute. So there's a bunch of different schedulers. Okay? By default, interval is going to use the computation thread pool, right? A lot of the overloads, I don't actually not sure with interval there is. Yes, you see that there's a second parameter that says I can actually specify on what scheduler I want this executed. So I could say, for example, scheduler, and then define what scheduler. So it's a level of abstraction above the threading kind of thing, right? So here you can see that now I've got my main thread. However, the Rx, the actual interval is being emitted on a different thread. Now let's go look at this one. And here is where you can start to play with aspects of the threading. Before you saw that I could pass in the scheduler. I could say scheduler on computation. There's actually a different way to do that also. If you don't have your observable with a parameter that allows you to pass in the actual scheduler, you can actually call a function that says what to subscribe on or what to observe on. So here what I'm saying is take an observable and I want you to observe it on the scheduler computation. So there's two things here. If you look, there's a subscribe on, and there's an observe on. So what is the difference? Subscribe on means, on the observable, means on what thread am I going to do the work, right? Observe on means on what thread I'm going to notify the observables on, the observers on. It's a little bit twisted. I want you to know that this is what it allows you to control. Get your head around it a little bit later on, okay? And I'll be at the booth tomorrow, so we can hash it out a little bit.
So part of that's important for, say, long-running observers.
Yes. So the question is, this is important for long-running observers. So the actual guidelines say that you shouldn't really use that kind of construct. You should actually create observables that encapsulate the threading. And if you want to modify that behavior, then you pass an actual scheduler, right? Just like interval does. Because this is kind of, it can get complicated and it can lead to deadlocks, right? Because it's like, okay, I'm going to subscribe on this, I'm going to observe on this and stuff like that, okay? So, last thing I want to show you is this concept of hot and cold. And it's actually not easy to create this. This doesn't work too well, and it's a little bit of a hack, but it's important for you to notice there's two concepts. Everything that I've been showing you so far is basically what's called a cold observable. In a cold observable, what happens is that I have this observable, and then as things subscribe to it, it starts to emit its data, right? Every time someone subscribes to it, it's when it starts to emit data. Until someone doesn't subscribe to it, it won't start to emit data. Every observer is going to get their own copy, an exact replication of that data. So if I have an interval and I have 5 subscribers to it, they're all going to get that data. Yes, question?
If they subscribe at different times.
They're all going to get, like if I loop through 5, from 1 to 5, they're all going to get 1 to 5, right? The difference now, there is another concept which is called a hot observable. In a hot observable, what happens is that the observable is just constantly streaming out data, right? And there you're really kind of sharing the data. So if you subscribe, you're going to get whatever data there is at that time, right? It's not going to kick off the observable. So a hot observable would be kind of like the mouse movements kind of time, right? A stock ticker that's just emitting data, and then you subscribe and you start to get that data. And this is an important concept to distinguish because, you know, cold observables don't actually kick off until you start to subscribe to them. Okay, it's not easy to kind of like simulate a hot observable. I don't know if I actually got this to work at the end. But basically, what I'm doing here is, okay. So there's publish and connect, and let's see if this works, and then I'll tell you what it does. First, wait, second, first, second. So you see that the second is like it hasn't started from initially, it's just like picked it up. What I'm doing here is there's some methods in RxJava that allow you to convert a hot observable to a cold observable, or a cold to a hot. So here what I'm saying is go and do this observable and then schedule this on a new thread. Okay, so I don't want to use the main thread, and then publish. What publish is going to do is return this concept called a connectable observable. In essence, think of it as like this virtual observable that basically allows you to kick off the observable without really subscribing to it, right? So it returns a connectable observable, and then on that, as soon as you call connect, it's when it starts to kick that off, right? I do a thread sleep, I start to take 5 first, and then, well, it doesn't actually start to kick it off. It will kick it off on the first connection. I do a take 5, and then I do another take 5 here. So you see that there's a gap, and then it just starts to take that. And actually, that example isn't too good, so ignore that. I want to work on this to make it even better. Okay. Yes, question.
If I call observable.connect at the end of, you don't have any number, so just before while loop.
Over here, cool, observable connect just before while loop. Where?
The while loop down.
Oh, here?
Happen.
Well, let's see. So you're saying, take this guy, put it here. You want to keep the while loop in there?
Yeah, I mean, I'm just concerned about observable. Can you run it?
Let's run it and see. That's the beauty of Rx. You never know what happens. Seriously. You're like, how the hell did that happen? Okay? If that didn't make any sense whatsoever, it's okay. Okay, we've got a couple of minutes left. I just want to go through a few more slides. Is this the silver bullet? Yes, we finally found the silver bullet. It's game over for everyone else. Of course not. Where does Rx help? There is no, by the way, you probably know there is no silver bullet, right? You'll be surprised people still think there is a silver bullet. It's called, it's called React. React.js, React Native, that's the silver bullet. Asynchronous code, this is where it helps. It helps in combining results. It helps with when you're dealing with events. It helps with errors. It tries to make the whole error handling much easier. Most importantly, and I think this is the most important aspect, it adds a layer of abstraction. Right? So you know how, like, if you were in my talk this morning when I was talking about functional programming, I said functional programming elevates it to the level of functions being the primitive building block, right? Here, what we're doing is elevating that for the building block to be observables, right? This now becomes our observables, and we're starting to apply functions on these observables. And if you basically think about it, observables is nothing more than streams of data, right? That's where the whole concept of stream comes in with reactive extensions. It does have some issues, obviously. It has a learning curve. You have to think in functions. You have to think in streams. It can still cause havoc in your code. You dealing with schedulers isn't easy. It doesn't automatically give you parallelism. By default, Rx is not, it's not threaded. It's single threaded, right? So all of these things are still there, it's not the silver bullet. There are places where RxJava can be used and places where it doesn't make sense to be used, right? Fortunately, this has actually been around for quite a while, right? There's enough documentation and guidelines, and I'll show you some in a minute, that can give you some better background. You had a question?
Yeah, how does something like Reactive Extensions compare to like an actor model framework or akka or something like that?
So it's more or less similar. Like akka is kind of similar basically to this whole RxJava thing, right? They all follow this concept of reactive programming. Okay. In fact, there's another manifesto. Well, it's not actually, yes, it's kind of like a manifesto, which is called the Reactive Programming Manifesto, which they're kind of trying to create this like higher level API, and there's implementations. There's akka, there's RxJava, etc. Okay. To learn more, I recommend the reactivex.io website. There's a whole bunch of tutorials. There's some very good ones on there. There's the Lee one, Lee Campbell, Introduction to Rx. Now this is in C#, because remember, Rx came from C#. He made a website called intro-to-rx.com. It's now available as a downloadable book. It's excellent resource. Really excellent resource for learning. You might have, it's C# syntax, but nothing that is going to cause havoc. You can pick it up very easily. Then there's a bunch of videos. The introduction to reactive programming by Andres Saltz, who's the guy that's done the RX Marbles, is a very short blog post which basically gives you the gist of what I've been saying. So that's actually a good resource as well. And then there's a whole bunch of tutorials. Jafar Hussain works at Netflix, and he's done some very good work with Rx. He's actually they've implemented RxJS, which basically gives you the same thing that you've seen here with RxJava, but with JavaScript. So you can do away with promises and all of those callbacks hell, and use the same on the JX side. On the JavaScript side, okay? Last but not least, this I already showed you. RX Marbles is very good to kind of get a visual aspect of how the combination, all of the operators work. Okay, and that's it. Well, thank you. We're done.